Okay, so in our previous class, we have treated right-angled triangles where we played around the Pythagoras theorem. We also made use of the SOHCAHTOA, the trigonometric ratios, to solve problems that has to do with right-angled triangles. Now in this class, the introduction of this class, Sine Rule, we have told you that we have cases whereby we have angles that are not right-angled triangles. We also have angles that are acute angles and obtuse angles, and they are triangles. How do we play around with those or solve problems that has to do with those angles? Now, in most of that, the basic trig ratios or the Pythagoras theorem will not be too favorable for us. So we introduce what we call the what? The sine rule. In our last class, we have derived the sine rule from acute angled triangles. Don't forget acute angled triangles, and we have them in this, such that we have said that if you have a triangle, given this, you notice this is an acute angle, an angle that is less than what? 90 degrees. So that if this is A, B, and C, that is side A, B, C, you have, the first thing we dealt with was what? The labeling, right? This will be small letter what? C. This will be small A, and this small B. Where the small letters is used to denote the what? The sides, and the capital letters, the block letters, are used to denote the what? The angles. So we said one condition that you can make use of the right angled triangle is when you are given two angles and one side. You can make use of the sine rule to solve that problem. So now we have that sine A, which is the sine of angle A. Say this is an angle, this is angle A, this angle B, and this is what? Angle C. So the sine of angle A is all over what? Side A. And it's equal to the sine of angle B all over side B. It's also equal to sine of angle C all over side what? C. So this is the sine formula as we derived in our last class. Now we have a problem. We have that a triangle is given such that angle A is what? 54 degrees. Angle B is what? 67 degrees. And side A is what? 13.9 meters. So you have that. You are given this to be what? 67. You have this. Okay, this, we can't make use of this because this is a right angle triangle. So for this problem, we have an angle to be this. If this is A, B, and C, angle A is what? Which is this angle? Is 40 what? Sorry, 54 degrees. Angle B is what? 67 degrees. We weren't given what? Angle C. And if this is angle A, this is what? Side A. This is what? Side B. And here is what? Side what? C. Side C. So, tell me, what is the question statement? Read out the question for me, please.
In ABC triangle ABC, A is equal to 54 degrees, B is equal to 67 degrees. Small a is equal to 13.9 meters. Find small b and small c.
So we are to look for what? Side C and side what?
B.
So we have to look for
Side C.
this side and this side. We are giving this side to be what? 13.9 meters. Now, the first thing we will do is looking for this angle C. And that is very simple. You remember that the sum of angles in a triangle is what? The sum of angles in a triangle is what? 180 degrees. Is that correct? So now, we are given two of the angles, which means if we take the sum of the two angles we are given and remove it from subtract from 180, we are going to be having the what? The third angle. So let's look for angle C. Angle C is equal to 180 degrees minus 67 degrees plus what? 54 degrees. And 54 plus 67 is what?
121.
121. So 180 minus 121.
161.
Is 61 degrees. So therefore, this angle is what? 61 what? Degrees. That's how we look for that angle. So that if we add this angle to this angle to this angle, it's going to give us a total angle of what? 180 degrees. Is that taken?
Yes.
Can we proceed?
Yes.
The next thing we have to do, we can now look for any of the sides. Now, we know sine, we know A, we know B. Now we also know C. That's the angles ABC. We know them. So we can now take any of these ratios to do what? To look for the small sides. Are we together? Yes. Since we are given A, we can start with A. We can start with A. So we are going to be using this and this to look for small side B. And when we are done, we use any of the ratios here to look for what? Side C. Are we ready?
Yes.
So, since we've known that, let us now look for B. We have to find B and what? Side C. So, to find side B first, we'll have that, we'll take these two. We have that sine A is equal to what? A, which is the same thing, is over A equal to what? Sine B is equal to what?
Over B.
Side B. Sorry, side B. Now, we know this. We have sine A. What is A?
54.
A is what?
54.
54 degrees all over. Side A is what? 13.9 is equal to what is B? 67 degrees is all over what? B. So you see that the only thing we don't know there is what? Is side B. So what do? We cross. And when we cross multiply, we are going to have that 13.9 times sine 67 is equal to what? B times what? Sine 54. Now, we are looking for what? B. So with DSBB, right? DSBB, divide
DBSB.
divide both sides.
DBSB.
DB, yes. DBSB. Divide both sides by what? By sine 54. The essence of doing that is so that what? B will stand alone by sine 54 degrees. So if we do that, we are going to have that 13.9 times sine 67 degrees is all over what? Sine 54. And that's equal to B times sine 54 is divided by what? Sine 54. So here sine 54 we do away with what? Sine 54. And we're left with the fact that B is equal to 13.9 sine 67, right? Is all over what? Sine 54. Are we good to go? Are we good to go? So now, let's take the signs now. What is sine 67? Sine 67. So, coming from here, sine 67 is what?
0.92.
So that will be 13.9 times what? 0.92 is all over. What is sine 54? Sine 54.
0.80.
0.80. Are we together? Yeah. Don't forget it's equal to what? B. That is what we are looking for, side B. So now, 13.9 times 0.92 is what? 13.9 times 0.92. 12.7 divided by 0.80.
So 15.9
is equal to what?
15.985.
B is equal to what? 15.985. Let's 5.
Yes, it's 5.
Approximately 9. So this becomes our what? Side B. Are we together?
Yes.
That becomes side B. Do we understand?
No. Yes.
Yes, who said they don't understand? Please ask your question.
From that B, 13.9 times 67 over 6.
Okay, now, this is what happened. You understand up to this point, right? What we did here, divide both sides by this. Now, this times this. This times this. We are looking for what? B. To make B stand alone, what do we do?
Divide both sides.
Anything attached to the B, we divide, use it to divide both sides, right? That is what we have done here. And what is attached there is what? Sine 54. That's why we have divided both sides by what? Sine 54. If you do that, B sine 54 divided by sine 54. Whatever you do to the right hand side, you also do to the what? Yeah. To the left hand side. That's why we have sine 54 also here. Are we together? So when that divides, we are left with what? B. And this is 13.9 times sine 67 is all over what? Sine 54 that we divided both sides by. Is that clear now?
Yes.
Yes, please.
How do we get 13.9 times?
60.9 was given to us in the problem as side. So we use it, look at this point. From the formula, we are given A, we are not given B. And in the sine formula, we have that this is equal to what? This. So since we know this, and we know this, but we don't know this, that's why we decided to work with this first. Are we together? And in working with this, all we have done so far is looking for this. So we, at this point, at the first point, which is here, if you see this is an exact of what is here. So we cross multiply. So that B is multiplying what? Sine A. And sine A is multiplying what? Sine B. That is what we have here. You are given A to be what? 54. And you're given B to be what? 67. So this is a replicate of that. You have just substituted. And we came to that point. Yes, please.
Sir?
Yes, please.
We found C to be 61. That's sine C.
We found C. That is the third angle in the triangle. It's not the side. When we did, that was why, if you look at what we did, we took the sum of angle in a triangle. You know, a triangle has 3 angles in it, right? And we were given 2 of each angles. And it is a law, or it is a rule that the sum of angles in a triangle is what? 180. That's the total. When you add the 3 angles in a triangle, the values, it will give you up to what? 180. So now we are given 2 of those angles, which is 67 and what? 54. So if we add the 2 we are given together, we have now removed it from the total. This, okay, for instance, we have 12 or 14 in this class. Are we together? And I want to know the total number of students that are not in school. We have marked your register, and 10 persons out of 14 answered what? Present. How will I know the number of persons that are not in school?
14 minus 10.
14 minus what? 10. 14, which is the total number of students in the class, minus the people that answered what? Present. That will now give me the total number of the students that were absent. So that is what we have done here. We were given 2 angles, and we were not given 1. We were not given 1. But the sum of the angles is 180, which is this. So if you remove the sum of the 2 you are given from the total sum, what is remaining is the other fraction. That was how we got 61.
Can we use that sine C to solve for this?
To solve for side B, we can only use sine C to solve for B if we know C. The reason why we use A is because we know A, and you cannot solve for 2 unknowns at a time. Are we together? Imagine, let's say someone is trying to use this. You have this to be what? B to be what? 67. You were given what? We have solved C to be what? 61. Were you given B? No. Were you given side C? No. So you cannot do anything because there are 2 variables, 2 unknown. But look at this one. Even if we are not given this one and we are given this one, and we are asked to look for this one, we can use this one and this one to solve, because at least we know one of the variables. Is that taken?
Yeah.
Is that taken?
Yeah.
Any further question? Okay, if there are no further question, the next thing we'll now do is to look for what? Side C. And in looking for side C, we can use this function and this function, or we can also use this and this. You know why? Because we know this. We know this to be what? 15.99. And we know this to be what? 13.9. Are we together?
Yeah.
So you, in your own corner, you can look for C. Take time to look for C before I will do the work. Let's. Okay, welcome back. I believe you've done a very nice work. Now, let's run through to look for C. Now, looking for C, we can make use, since you already know A and B, we can make use of any of these. Well, let's go with this.
Yes.
We'll have that sine P over what?
Small
B is equal to what?
sine C.
Sine what?
C
Over
C.
over C. Now you've done this, so let's make it faster. Now what is B?
67.
67 is over what? What is
16.
16?
Yes.
Is it what we, okay, you approximated?
Yes.
You approximated to 16, okay?
Yes.
Let's go with this. What is C?
61. Sine 61.
61
Over C.
over what?
Multiply.
This is what we are looking for, right?
Yes.
So what should I do from here?
Cross multiply.
And if I cross multiply, I'm going to have that what?
16 times sin 61
Sine 61
equals to C times sine 67.
C times
Sine 67.
60 what?
All
7.
over 6.
So now we divide both sides what?
By sine 67.
The BSB, divide both sides by what?
Sine 67 to make
Why are we doing that?
to make C stand alone.
To make 6 stand alone. So we have that 16 times sine 61
all over
all over
sine 67.
sine 67
Equals
is equal to what?
C
C times what?
sine 67.
67 over.
sine 67.
So what will happen? This will do what? And we are left with what? C is equal to what? 16 times